Hey, so I am working on this application, this problem where we have two bottle different sizes coming down the same line on the factory. And we want to test for cap presence and cap absence, but not only that, we want to make sure that the cap is seated all the way down because it's been causing some problems. So we are challenged with the fact that this really only gives us about one revolution when the cap is on. So we want to test when it's seated all the way versus when it's seated about halfway, where it still can come off when it gets further down the line and causes a lot of spills throughout the day. So just to give you some background and context, I've tried multiple things. I've tried vision, I have tried some other lower resolution sensors, including this one as well. So I've tried different lasers on it, but I don't get a really great switch point. So I have moved on to my LM150, which gives me about 150 millimeters of resolution of sensing range, and it goes all the way down to 0.001 of millimeters. So as you can see here, I put it under the laser. And by the way, this is IO-Link. So I've got this connected to my IO-Link master on my desk, and you can see the web server of that. So you can easily see the measurement one value that we're looking at. So right now, with the cap seated all the way down, we have a lower limit threshold of 63.4. So if I go all the way up to where it's just seated on a flat surface here, oops, it's kind of hard to get it. There. We have an upper range of 59.8. So that gives us the min and the max here to work with so that we can set a good threshold. So what I want to see is this seated about halfway around, and this is still on here, but so that is right at the middle point. So we're looking at about 62.6. And this is just based on how I have this mounted. You'll have to mount it yourself and see what you see so that you can set the right numbers. That's at 62.17. So that gives us some really good information. So if I don't have it on, you get the full range of the sensor there. And if I have it slanted, that one's an easy one to detect. So that's kind of where I'm at. I like this. I think this is going to give you a lot more data and information to make a better decision. Now, you are going to require a sensor that detects which one is coming down the line that this sensor is going to expect. So you're going to need a logic decision point, some PLC, some smart relay, and you're going to need a photoelectric sensor that tells you the color so that you can identify the blue versus white. We've got sensors that will do that, and that's not a problem. So there will be, a little bit of programming there that you'll have to do. It's not too bad. I can help you with all of that. But yeah, so this is what I've got working so far. This is probably the solution I have to move forward and to test actually on the line. So let me know if you have any questions.